All right, so it looks like we're live. This is my first time attempting any sort of stream on StreamYard. So if I make any egregious errors, feel free to call me out or don't. Either way. So yeah, as my description says, I'm here with my buddy Robert, who
Heyo.
is he's a physics guy. Do you want to introduce yourself a little bit?
Hey guys, I'm Robert, or as on my socials I call myself Sulfa Powder. I'm an undergraduate. We both go to the same college. I'm a physics major, mathematics and Spanish minor. But this summer I'm doing some undergraduate research. Unfortunately, I had to be remote and whatnot. So I can share my screen real quick and show you a bit of what I do. Let's make sure this works.
Oh, are you gonna try to screen share the math stuff?
Yeah,
is it math or is it like modeling?
No, it's scripts that I write, so it'd just be a bunch of coding and shit.
Oh, okay.
All right, I can't seem to get it to work. Fucking Firefox blocking it. But basically, what I do is I'm studying active galactic nuclei, which are blazars. Blazars are supermassive black holes in the center of galaxies that have big variance, and so they shoot out a jet of really high energy particles, and we receive those as gamma ray bursts and X-rays. And then so I work with a telescope. I'm working with 3 telescopes this summer, Swift, NICER, and Chandra. And what we do is just take in data from certain sources, and then you model them, write code about it, and see what the variance means, predict what's going on with it. So right now, the NGC 2992 is the AGN, the active galactic nuclei, that I study. So that's my black hole. So,
all right, that's pretty sick. It's your black hole. I gotta ask: does gravity exist?
It's like that old old parrot goes, Occam's razor. At some point we got to ask ourselves: is it really easier to just say, well, it probably does, versus whatever the fuck else anyone else would say?
I don't mean to spoil too much for the video, right? But as far as I can gather, flat earthers think that the differences in why stuff falls and why some stuff floats is due to density, which is partially true. But they say it's exclusively due to density, and you don't need gravity for some reason. But yeah, before we get into the video, I wanted to just sort of say, sorry for not posting in a month and a half. I've been pretty busy. In fact, I was taking physics. That on top of a bunch of other stuff. But I do have plans. I've finished a video and a half, although the video I finished, I decided against uploading it. Oh, and it looks like we lost Robert. He'll probably be right back. But yeah, so I have finished a video, but I decided against uploading it because I didn't think it represented what I wanted to show on this channel too much. And then I have another video about proboscidity and phylogeny, which I've pretty much finished the script to, and I just need to record the video. Welcome back, Robert.
I'm back. Sorry.
You're good.
I'm on my Linux partition, so sometimes just Linux just doesn't allow me to have certain permissions, so it just kicks me out sometimes.
Yeah. Well, hopefully my mic's been, or not my mic, my mouse has been spazzing out recently, so I'm hoping it doesn't. I was in a stream the other day and it accidentally just closed the StreamYard tab, so I hope that does not happen.
Yeah.
Just in case, make sure you have something entertaining prepared, right? Did you get the sketch comedy script prepared?
Oh sure, yeah, I got it.
Yeah. All right. So do you want to start the video?
Yes, I'm not in control of the video. You are, but yes, let's start the video.
Yeah.
Let's go.
Okay. So here, yeah, like I said, it's "Gravity Does Not Exist" by Eric Dubay.
2.5 years old, 67,000 views. All right, let's watch this.
Yeah. So from what I hear, Eric Dubay is actually kind of like the gateway flat earther for a lot of people. So when I was trying to decide this, I was trying to decide between this video and another of his videos is 100 proofs of the flat Earth or something. But the 100 proofs video, it wasn't very entertaining. It was mostly just like very specific questions about like photographs and optical illusions, and I was like, there's no way I'm gonna be able to answer like any of these just offhand. So yeah, I ended up choosing this one. This was also pretty entertaining because it's a flat earther. I mean, what can you do? All right, so I'll give it a start. Okay, so I was telling Robert about this earlier. This intro sounds like Eiffel 65 wrote it. Shit sounds like I'm blue.
It does indeed.
That's so good. Yeah. Ooh.
Yo, listen up, here's a story about a guy that
If you fill a balloon with helium, a substance lighter than the nitrogen, oxygen, and other elements which compose the air around it, the balloon will immediately fly upwards. If you fill a balloon with hydrogen, a substance even lighter than helium, the balloon will fly upwards even faster.
Crazy.
If you blow a dandelion seed out of your hands, a substance just barely heavier than the air, it will float away and slowly but eventually fall to the ground. And if you drop an anvil from your hands, something much heavier than the air, it will quickly and directly fall straight to the ground.
I forgot to mention this. Me and Robert, we're both underage, so we're playing a sober drinking game, I guess. We were going to take a sip, take the rules from Dapper Dino's, his streams. Take a sip every time he gets something right or if he gets something really, really wrong and stupid.
Sounds good.
I thought that would be fun. Yeah, so I got Propel. And what did you say you had?
I got some coffee, black coffee.
Fun. It's a little late for that. Nah. All right.
Now this has absolutely nothing to do with gravity. The fact that light things rise up and heavy things fall down is simply a natural property of weight and density.
Nothing to do with gravity. Absolutely nothing.
So, can I explain a little bit of what I think about this?
Yeah,
Just
and also,
general?
by the way, if you ever want me to stop the video, just say pause or something. Or if you just start talking, I'll try to get it.
So, the most basic argument as to like what keeps us on the Earth if the gravity does not exist is that the flat Earth is moving through space at a constant speed, and then we are just staying flat on that that goes on that plane that goes 9.8 meters per second, and that's all we experience is gravity. But in that state, if you put a glass with both water and oil on it, some with different densities, they wouldn't move because there's no inertia, there's no acceleration, nothing to shift the densities. They wouldn't just do anything because they're going at a constant speed. So
yeah,
well, that would.
To be fair and defend the flat earthers a bit, they don't think Earth is going through space. I'm pretty sure most of them are geocentrists. Would it even be geocentrist if it's a flat plane? If it's not
well, don't they still think that our solar system is going through somewhere?
No. So I've very preliminary, like I've barely looked into this, but apparently they think that the sun and the moon just sort of like float in circles around the Earth, and they're only like 3,000 miles away or something.
Okay.
And I think the moon is there's like competing theories. I use that word very lightly. That the moon is either a hologram or it's a light emitting source like the sun. So
hologram, interesting.
Yeah. Okay, so I'll keep it going.
That is very different from gravity. Gravity is a hypothetical magnetic-like force possessed by large masses which Isaac Newton needed to help explain the heliocentric theory of the universe.
Yeah, see, so they're not
Lady
heliocentric.
Blunt says, most people in England have either read or heard that Sir Isaac Newton's theory of gravitation was originated by his seeing an apple fall to the earth from a tree in his garden. Persons gifted with ordinary common sense would say that the
Actually,
apple
pause it real
fell to
quick.
Earth because
All right.
This theory the myth that Isaac Newton had the apple fall on his head was actually, I think, which Enlightenment thinker was it? Might have been Voltaire, I think, that started the myth as a way to try to explain gravity to his students or whatever. So it was like a joke to him that he was trying to explain away why the apple would fall on Newton's head and how he thought of gravity. So that's where it comes from, which I thought is an interesting little fact there.
Yeah. Also, while we're paused, I think I'm just going to address like the idea of specific gravity first. So it's basically the idea gravity is a constant downward acceleration, but it's not necessarily a force, right? So you have acceleration due to gravity, which is going to be the same for everything with different mass. But the force experienced by that gravity is not going to be the same. And so the specific gravity is the force of gravity per unit of volume. And so that's why objects that are less dense get displaced, right? Because they have a greater downward pulling force than whatever object is surrounding them. So that's why things denser than water sink. It's because of gravity. It's not like you can just say, oh, well, things fall down because they're more dense. Like, yes, they're falling down because they're more dense because of gravity. Anyways.
Right. So if we lived in a gravitationless world, they would just stay inertial.
Yeah.
In any kind of substance you were doing your different liquids in or whatever. So.
Yeah. So interesting.
That is quite dumb.
For bulk, it was heavier than the surrounding air. But if, instead of the apple, a fluffy feather had been detached from the tree, a breeze would probably have sent the feather floating away.
Okay, so also another thing, and I know this people probably don't believe we went to the moon, but there's a cool video of an astronaut dropping a feather and a hammer and them hitting the ground at the same time, because gravitational acceleration is constant.
Yes, indeed. Apollo 17, I think that was.
I don't know, but it happened.
Indeed.
And the feather would not reach the Earth until the surrounding air became so still that, by virtue of its own density, the feather would fall to the ground.
So by that logic, then the feather would just kind of float forever, just stay forever floating at some layer in the air, mid above your head or something.
Yeah. If there was never any downward force that was pulling the feather down, then it wouldn't come down.
Famous flat earther in the early 20th century gave lectures all over America against Newtonian astronomy. He would begin by walking on stage with a book, a balloon, a feather, and a brick, and ask the audience, how is it that a law of gravitation can pull up a toy balloon and cannot put up a brick? I throw up this book, why doesn't it go on up? That book went up as far as the force behind it forced it, and it fell because it was heavier than the air, and that is the only reason.
Oh my god. It went up until the point where the initial velocity was matched by the downward acceleration, so the negative acceleration, right? You have an acceleration going in the opposite direction of the velocity, so whenever it reaches its peak, it has a velocity of 0, and then its only acceleration is gravity. It falls. God.
I find the syntax that he uses very interesting. He uses words like density and heavy intermittently, what's the word? Interchangeably. And those don't equate. Something can be heavy and not dense. I mean, you got a huge thing of styrofoam that is heavy. It's not necessarily dense. Those are relative words as well. But he also uses words like force when he denies gravity. Gravity is a force.
Yeah. Well, and it's also it's interesting that he's using the word heavy, because heavy implies weight. And without gravity, there is no weight.
That too.
So, yeah.
I cut the string of a toy balloon. It rises, gets to a certain height, and then it begins to settle. I take this brick and a feather. I blow the feather. Yonder it goes. Finally, it begins to settle and comes down. This brick goes up as far as the force forces it, and then it comes down because it is heavier than the air. That is all. David Wardlaw Scott says, any object which is heavier than the air and which is unsupported has a natural tendency to fall by its own weight. Newton's famous apple at Woolsthorpe, or any other apple when ripe, loses hold of its stalk. and being heavier than the air, drops as a matter of necessity to the ground, totally irrespective of any attraction of the Earth. For if such attraction existed, why does not the Earth attract the rising smoke, which is not nearly so heavy as the apple? The answer.
Robert, do you have an answer to that?
I'm not getting what they're trying to get at here. It's like that's not how densities work.
Yeah, I mean, I guess I don't know.
It's gonna fill up. Cork. That's how cork works. This is what who was it? Archimedes. The whole Eureka thing with the bathtub.
Oh yeah.
Like that's how water and densities work, and that's the. There's another one too about him going on like a tree and whatnot. The fish.
Yeah.
Tree sinks and comes back the next day.
Well, let's play this and see the real reason why smoke rises.
The answer is simple. Because the smoke is lighter than the air, and therefore does not fall but ascends.
Okay, that I don't know why, that one sentence reminds me of that video of the Irish dude who's like, what's heavier, a kilogram of steel or a kilogram of feathers? A kilogram of steel, because steel is heavier than feathers. Like, that's just where my mind goes.
Gravitation is only a subterfuge employed by Newton in his attempt to prove that the Earth revolves around the sun, and the quicker it is relegated to the tomb of all the Capulets, the better will it be for all classes of society. Thomas Winship says, "The law of gravitation is said by the advocates of the Newtonian system of astronomy to be the greatest discovery of science and the foundation of the whole of modern astronomy. If, therefore, it can be shown that gravitation is a pure assumption and an imagination of the mind only, that it has no existence outside of the brains of its expounders and advocates, the whole of the hypothesis of this modern so-called science fall to the ground as flat as the surface of the ocean, and this most exact of all sciences, this wonderful feat of the intellect, becomes at once the most ridiculous superstition and the most gigantic imposture to which ignorance and credulity could ever be exposed."
So I guess
God.
Fuck buoyancy, I guess. Yeah. Damn.
He's using very loaded language, like flat as the ocean or something. That was definitely a reference to like a flat Earth and not, horizons. Yeah. Is gravity a false god? That's apparently where we're going to next.
Einstein's theory of relativity and the entire heliocentric model of the universe hinge upon Newton's law of gravitation. Heliocentrists claim that the sun is the most massive object in the heavens, more massive even than the Earth, and therefore the Earth and other planets, by law, are caught up in the sun's gravity and forced to orbit perpetual circles and ellipses around it.
I was just imagining like the finger quotation marks for like that whole thing.
Yeah.
Gravity.
Congrats.
And the Earth is orbiting around the sun.
You got it. That's exactly right.
Yeah, I guess drink for being right. All right.
Man. Wow.
They claim that gravity also somehow allows people, buildings, the oceans, and all of nature to exist on the underside of their ball Earth without falling off. Now, even if gravity did exist, why would it cause both planets to orbit the sun and people to stick to the Earth? Gravity should either cause people to float in suspended circular orbits around the Earth, or it should cause the Earth to be pulled and crashed into the sun.
What are your thoughts on that one?
So the basic law of gravity is that you have GMM over R squared. So the reason why we have both the sun and Earth rotation and U and the Earth acceleration due to gravity is because the Earth and sun have a much more magnitude relative to each other versus U and the Earth. I mean, that is like the sun is like 1,000 times bigger than the Earth, so there's a little bit of attraction there, enough to make it orbit around it. But U versus the Earth, that's like a few 10 to the 24 times the amount of magnitude bigger than U. So like, of course, the U around the sun, it won't matter as much as U around the Earth because that's just so much closer. You're literally on it. That's why. That's the whole law of inverse proportion.
Well, and also I think his point was that if the Earth orbits around the sun, then why don't we orbit around the Earth? Because gravity. And I think that's a very poor understanding of how orbits work, right? So basically, anything in orbit's in free fall. It's still experiencing the downward acceleration of the Earth, but the angular velocity of whatever's orbiting is just fast enough so that it doesn't ever reach the Earth. It's changing its angle at the exact at a constant so that it can stay in a circular path around it without ever actually touching it.
I mean, you could literally do it like a foot off the ground if you went around the Earth like,
God,
you know,
you'd
like
be going so fast.
2-3 times per second. Yeah, like you could do it. You could just float right above the Earth, but you had to go like
Jesus.
12, 20, 30,000 miles per second. So
Easy.
it's a nice trade-off.
Let's
Yeah.
do it.
What sort of magic is gravity that it can glue people's feet to the ball Earth while causing Earth itself to revolve ellipses around the sun?
Yeah.
The two effects are very different, yet the same cause is attributed to both.
Yep.
Furthermore, this magnetic-like attraction of massive objects gravity is purported to have can be found nowhere in the natural world. There is no example in nature of a massive sphere or any other shaped object which, by virtue of its mass alone, causes smaller objects to stick to or orbit around it.
So, are there any large spheres in the natural world that have gravitational forces that pull other stuff towards it? Are there any large spheres?
What do they think the other planets are? I mean, like, we have observed both sides of Mars. You can literally do that with a telescope in your own backyard. Like,
Yeah, but
it's
you've
not
never
that hard to
been
deny
Mars.
it.
But you've never been to Mars, have you?
Yeah, but we can see that there's two sides to it. I mean, these telescopes are not that hard to see both sides of Mars. I mean, it's a relatively close object in the sky.
Yeah. Well, and I mean, like, I don't know. I mean, I guess it's a lot easier to argue something if you just outright dismiss the fundamental principle of it.
Yeah, exactly.
You know, it's whatever that quote is. It's like it's hard to argue against, or it's hard to argue against a smart person, but it's impossible to argue against someone who's like ignorant.
I know what you mean, yeah.
Yeah, you know, if you're just outright dismissing, like, oh yeah, the sun is a large sphere that has gravitational, what would you say, force or energy? I guess it has gravitational attraction. Yeah, the sun is a large sphere that has gravitational attraction. Well, the sun's not a sphere, and it's not pulling anything towards it. Like, okay, I guess in this universe that the flat earthers live in, that's true. I don't know. Right.
There is nothing on Earth massive enough that it can be shown to cause even a dust bunny to stick to or orbit around it. Try spinning a wet tennis ball or any other spherical object with smaller things placed on its surface, and you will find that everything falls or flies off and nothing sticks to or orbits around it. To claim the existence of a physical law without a single practical evidential example is hearsay, not science. Lady Blunt and Albert Smith wrote, that bodies in some instances are seen to approach each other is a fact, but that their mutual approach is due to an attraction or pulling process on the part of these bodies is, after all, a mere theory.
Why then do things approach each other? What?
I genuinely think that the first time they saw like a picture of a satellite in space, they just thought it was floating and said that's not possible, and now they don't understand orbitals or anything like that, and so they refuse to learn anything about them because they see a picture of a satellite and it confuses them. So now, like, it's so false. It's like we're not even speaking the same language of debate.
Yeah,
in terms of the science of it.
Okay, but I'm just going to summarize what he said. He said that we've never seen or observed any sort of attraction between macro level objects. And then he quoted someone that said, we have observed attraction between two objects, but we can't prove that it's gravity. So that's already not contradictory, right?
Right.
And then it's just straight up stupid. But yeah, back to the video.
Hypotheses may sometimes be admissible, but when they are invented to support other hypotheses, they are not only to be doubted, but discredited and discarded. The hypothesis of a universal force called gravitation is based upon and was indeed invented with a view to support another hypothesis, namely that the Earth and sea together make up a vast globe whirling away through space, and therefore needing some force or forces to guide it in its mad career and so control it as to make it conform to what is called its annual orbit around the sun. The theory, first of all, makes the Earth to be a globe, then not a perfect globe, but an oblate spheroid, flattened at the poles, then more oblate, until it was in danger of becoming so flattened that it would be like a cheese, and passing over minor variations of form, we are finally told that the Earth is pear-shaped.
So,
I've heard something about this. It was actually something that happened with Christopher Columbus, and Christopher Columbus apparently wrote in one of his journals that there was, the globe was pear shaped, and this is actually a joke, or it's, I guess, not a joke, but it's a misunderstanding, because obviously all of Christopher Columbus's wasn't actually writing his own notes. It was someone doing it for him, and apparently it was like a translation issue and whatnot, and they didn't understand why like one of the marauders, one of the map marauders was drawing their maps one way and it looked pear shaped on it, and that was the only other time like that it was confused, that some actual geographer had messed up a globe or something like that. So it still gets perpetuated a lot.
So you're saying 500 years later, the Earth is not a pear?
I cannot prove it. I guess actually I can't prove it. I could prove it, but I don't have any photos. I mean, they look like they got a pretty good photo here. So
yeah. They got a really good picture of the pear Earth. Yeah, it went from sphere to oblate spheroid to cheese to pear, I guess. That's the chronology of the shape of the Earth. So first of all, the Earth isn't any of those. It's closest to an oblate spheroid. It's actually like a geoid because there's minor variation even along like the same. What is it? Is it latitude or longitude that's north to south?
Latitude.
Okay.
It's, so yeah, like at the equator, you're actually a few thousand kilometers higher off, farther from the Earth's center because of the centrifugal apparent force.
Yeah. Well, actually, I looked it up, and it's not even. It's only like 200 kilometers or something. It's actually like pretty close.
Yeah. Okay.
But like I was just saying, like the Indian Ocean, just because it has a very thin oceanic plate versus like the thicker continental plates. There's deformation due to gravity, right? So like I could pull up the geoid. It looks almost like a sphere, and then you have these like super exaggerated spheroids where it looks all wonky shaped, but that's like magnified times 1,000 or something. That picture that always circulates. Do you know which one I'm talking about?
I think so.
Yeah. I could share it real quick. I'll do that. So, okay. So like here is the geoid, but it's magnified times like 1,000. Whereas this is what the actual shape is, which is almost a perfect oblate sphere, right? So you have like regions over here in the Indian Ocean where it's like a little bit lower, whereas regions up here in like Scandinavia, Northern Europe, that kind of stuff, where it's a little bit higher than it probably should be. But at the end of the day, it's very minimal differences.
Gotcha.
All right. Back to gravity not existing, I guess. Oh. Not that. I'm very qualified to do this. I started sharing our own thing. That one. Okay. So back to pear-shaped Earth.
All right, let's go.
Aploid.
I don't think we can hear sound.
Oh, shit. Okay. Yeah, that's my one problem with StreamYard. You have to click share audio every time you want to share audio. It doesn't. It's not like a default setting. Okay. All right. Now it should be good.
How is it that gravity is so strong that it can hold all the oceans, buildings, and people stuck to the underside of the ball Earth, but so weak that it allows birds, bugs, smoke, and balloons to casually evade its grips completely? How is it that gravity holds our bodies clung to the underside of a ball Earth, but yet we can easily raise our legs and arms, walk or jump, and feel no such constant downward pulling force?
Okay, so I think this guy actually thinks that Australians have to wear world harnesses. like, the gravitational pull is towards the center of the Earth. So any point on the Earth, you're being pulled towards the center. It's not like the bottom of the Earth, you just fall off.
That's such a hypocritical argument too, because we just got done with different, like, even by his own standards, different densities, can float in the air or whatever. So like your arm is obviously a lot less dense than your, like a lot less, whatever. It's less heavy. It's lighter. It should be able to, should be easier to hold a lot, and then your whole body weight. So even by his own standards, that just doesn't make sense.
Apparently, like I said, gravity isn't directly a force, it's a constant acceleration, and it's the same acceleration for everything. But force is mass times acceleration. And so if your mass, say you're a butterfly, is like 0.01 kilograms, you're experiencing way less force than someone like me who's like 70-ish kilograms. So the force is minuscule compared to that. And also he's saying that there's no downward pulling force that athletes feel whenever they jump. Are you saying, like, dude, every time like any basketball player just jumps, they just keep going? I guess they eventually hit the ceiling of whatever stadium they're in. What? I'm gonna go back 5 seconds just to hear that again.
Arms, walk or jump, and feel no such can easily raise our legs and arms, walk or jump, and feel no such constant downward pulling force. How is it that gravity can cause planets to revolve elliptical orbits around a single center of attraction? Ellipses by nature require two foci, and the force of gravitation would have to regularly increase and decrease to keep planets in constant orbit and prevent pulling them into direct collision courses.
So do you have any response to that?
I don't understand the point of the two foci. So one of the foci is the sun, and the other foci of the Earth-Sun ellipses is the center of gravity between the Earth and Sun, which is slightly off the Sun. So that's why our trip around the Sun is basically a circle, but it's just elliptical enough because that little offset of the Sun-Earth center of gravity being slightly off the actual center of gravity of the Sun, that we have the seasons. That's why the seasons aren't like drastically different. If Earth was any bigger, the elliptical would be a bit wider. So then it seems to be more drastic. This is why the storms on Jupiter happen a lot, is because Jupiter's elliptical orbit is a bit more. So they get these violent storms with the hot and cold changing gas all the time.
Huh. So, I didn't know any of that. That's actually all really interesting. Yeah. I didn't know that like the sun and the center of mass between the two objects is considered like separate foci. And then also I didn't think about Jupiter. But something I thought was interesting, he said, go back 5 seconds.
And the force of gravitation would have to regularly increase and decrease to keep planets in constant orbit and prevent pulling them into direct collision courses.
Yeah. The force of gravity is constantly changing because the radius is constantly changing. Yes, that's correct. Wait, he's right. Okay.
This guy likes to choose what parts of like vector math he does and doesn't like.
Yeah, that's very true.
Thomas Winship says that the sun's path is an exact circle for only about 4 periods in a year, and then of only a few hours at the equinoxes and solstices, completely disproves the might have been of circular gravitation, and by consequence, all of gravitation. If the Sun were of sufficient power to retain the Earth in its orbit when nearest the Sun, when the Earth arrived at that part of its elliptical path farthest from the Sun, the attractive force, unless very greatly increased, would be utterly incapable of preventing the Earth rushing away into space in a right line forever, as astronomers say.
What do you think of that?
So, like, I literally was just talking about this. It's such a minute difference, and that's why we get more experience with the tilt and tip of the Earth's axis than with anything else like this. I mean, that's the problem here.
Yeah. Wait, so you're saying this image that he probably pulled off of like Google is
greatly exaggerated? Yeah.
It's not to scale. What? And also, what he doesn't. Can you see my mouse on this?
Yes.
Okay. What he doesn't really seem to get either is that the gravity is always facing this way. So as soon as it passes, like directly, not parallel, was it perpendicular to the sun? Mm-hmm. It's still it has at least some x component to its gravitational energy. So it's experiencing x gravity all of this direction. So that's why when it gets to this point, its velocity in this direction and the x direction is still zero. Right, because it's even if it's getting less and less over here, it's still experiencing gravity this way right over here. So it's dumb, basically. Oh shit! I'm very good at this. I meant to hit play, but if you hit spacebar in StreamYard, then it just cancels the screen share. Anyways.
On the other hand, it is equally clear that if the Sun's attraction were just sufficient to keep the Earth in its proper path when farthest from the Sun, and thus to prevent it rushing off into space, the same power of attraction when the Earth was nearest the Sun would be so much greater that, unless the attraction were very greatly diminished, nothing would prevent the Earth rushing towards and being absorbed by the Sun.
So what do you think of that?
I'm not really sure what he's like trying to get at here. I mean, he's making contradicting assumptions about like what part of vector calculus he wants to pick and choose. So he's okay with like throwing a ball up in the air and catching it as it comes down in an arc, but he can't accept the fact that that's how circular vector, like the circular path would look like. Sorry, yeah. I couldn't think of the words to it.
So this is, I just realized that I was talking about the rotation in like the opposite direction that the diagram shows. Because it's counterclockwise and I was looking at it clockwise. But anyways, so let's say you're at this point and you start coming this way. He's saying that once you get over here, that the gravity would be too strong and it would pull you in. But that's assuming that the gravity is constant, like throughout this entire motion. It's not, or at least, I mean, I think the net speed or like the speed is the same, but like the x component of the velocity is not the same. So whenever you're going this way, you're also increasing in your x direction velocity. So even though you're experiencing greater gravity in the x direction, once you're closer to the sun, you have a higher initial velocity in that direction. So it still works out.
Yeah.
Because that's math.
Yeah.
Diminished, nothing would prevent the Earth rushing towards and being absorbed by the Sun, there being no counterbalancing focus to prevent such a catastrophe. As astronomy makes no reference to the increase and diminution of the attractive force of the Sun, called gravitation, for the above necessary purposes, we are again forced to the conclusion that the great discovery of which astronomers are so proud is absolutely non-existent. And N. Crossland says, we are asked by the Newtonian to believe that the action of gravitation, which we can easily overcome by the slightest exercise of volition in raising a hand or foot, is so overwhelmingly violent when we lose our balance and fall a distance of a few feet, that this force, which is imperceptible under usual conditions, may, under extraordinary circumstances, cause the fracture of every limb we possess.
Okay, so this is another thing I'm confused about. Does he think that, like, you shouldn't be able to hurt yourself when you fall
Yeah, so obviously this guy's never been with a girl before, but you
Oh my
should know
God.
that if he was anywhere near a girl in high heels and she accidentally steps on your foot, that hurts a lot more than getting your your foot stepped on by someone else in a larger shoe. Because high heels fucking hurt, man.
Well, no,
So he doesn't understand how the force per area works.
well, and also, once again, this is something that using that same logic isn't it contradictory in the flat Earth worldview?
Yeah.
Right? Like, does he? I honestly, I just can't even comprehend it because yes, I pick up my arm, and then yes, if I fall and I hit my head, one of them hurts, the other one doesn't. Okay.
Yeah.
It doesn't matter what's causing that downward force. If you fall and you hit yourself because of a downward force, you're gonna hurt yourself. That force could literally be due to anything. If you got shot out of a cannon, that would hurt when you hit a wall.
The two second derivatives of force are pressure and impulse in the derivatives of area and time, respectively. And those two are the determining factors in how things break. This is materials engineering. And so when you get ejected out of a car and hit your head, that's because the impulse of stopping a car going that fast in such a short amount of time converts the energy into your kinetic energy much at a greater rate than you slowly stopping your car at a red light.
Yeah, I agree.
Common sense must reject this interpretation.
Yep.
Gravitation does not furnish a satisfactory explanation of the phenomena here described, whereas the definition of weight already given does. For a body seeking in the readiest manner its level of stability would produce precisely the result experienced. If the influence which kept us securely attached to this earth were identical with that which is powerful enough to disturb a distant planet in its orbit, we should be more immediately conscious of its masterful presence and potency, whereas this influence is so impotent in the very spot where it is supposed to be most dominant that we find an insurmountable difficulty in accepting the idea of its existence. Heliocentrists claim the ball Earth is perpetually spinning on its axis at a mind-numbing 1,038 miles per hour, or 19 miles per second, and somehow people, animals, buildings, oceans, and other surface phenomena can stick to the underside of the spinning ball without falling or flying off. Take a ride on the Gravitron at your local amusement park, however, and notice how the faster it spins, the more you are pushed away from the center of spin, not towards it. Even if the centripetal, inward pulling force of gravity did exist, which it does not, the centrifugal, outward pushing force of the ball Earth's supposed 19 mile per second spin would also exist and have to be overcome, yet neither of these opposing forces have ever been shown to have any existence outside the imaginations of heliocentric scientists.
Okay, so that's stupid.
So, there is no equation for centrifugal force. It's an apparent force. It's an apparent force of some other opposing force, inward-seeking force to whatever's causing the whatever kind of spinning you have. So, in a gravitron, what the apparent force you feel is your inertia pointing at the perpendicular 90-degree out from the circle, and it's the normal force of the back of the gravitron that holds on your back, that is keeping you inward. That is the centripetal force.
Yeah.
That holds you in.
And also, can't you solve for centrifugal force with an F, using mass times your angular velocity squared times the radius of the circle?
Yeah, but it's not like an actual force. It's an apparent force. So
well, yeah, but even then, Earth's angular velocity is 2 pi over 24 hours.
Yeah.
That's almost nothing. When you square it, it'll be almost zero.
So he said it was a whopping 1,000 kilometers per hour that we're going at. The parallax of 1,000. Okay, so the Earth's diameter is 24,000. So if we're going 1,000 kilometers per hour, that is a total of 1/24th of the Earth every hour. Coincidence? Like that is how the Earth spins. So that's like 1 in 1/24 is not a big angle, and you don't measure how fast you're going around when you're spinning by the distance you go around a circle. It's by the change in angle.
Yeah. Well, yeah, that's what I was saying. So, like, when you have a centrifuge spinning super, super fast, that's because it's spinning at like 1,000 RPM or something.
Right.
So you're having your angular velocity. I forget what the variable is called. It looks like a peach, or butt, depending on how crude you are. But the angular velocity of a centrifuge is like 20 or something, right? So when you square that, it makes the apparent mass of the centrifuge or the test tubes in the centrifuge way higher. But like I said, since you're dividing 2 pi, so like 6.48 or something, yeah, or 6.28 by 24 times 3,600. So that's tiny.
Mm-hmm.
Yeah.
David Wardlaw Scott says, "We are not like flies which, by the peculiar formation of their feet, can crawl on a ball, but we are human beings who require a plane surface on which to walk."
It's the earth harnesses, my guy. That's how the Australians do it.
And how could we be fastened to the earth whirling, according to your theory, around the sun at the rate of 19 miles per second? The famed law of gravitation will not avail, though we are told that we have 15 pounds of atmosphere pressing on every square inch of our bodies, but this does not appear to be particularly logical, for there are many athletes who can leap nearly their own height and run a mile in less than 5 minutes, which they could not possibly do if they were thus handicapped.
Okay, I'm confused if he's referring to handicapped by 15 pounds per square inch, which is just atmospheric pressure. Is that even atmospheric pressure? That seems a little high, but I might be wrong. Or per square foot, I think is what he said. Are they handicapped by that, or handicapped by a constant downward force or downward acceleration that they still have to have if the flat Earth model is correct?
So they keep calling humans weak for not being able to, they either are underestimating the workload of muscles, or they're overestimating the force of gravity. So pick one, please. They seem to have some weird assumptions about what applies in physics and what doesn't. So
yeah. And also, I mean, even if the force of gravity is relatively high, because, I mean, think about it. We have things like elephants, which are already experiencing incredibly high gravity. I think the heaviest elephant is something like 1,600 kilograms or 16,000 kilograms or something. So it's very, very heavy. And then every time it takes a step, it has to double that force, right? Because it has to have the applied force in the down horizontal or the angular direction to go forward. Mm-hmm. But obviously, we evolved with these conditions, right? It's not like we got here and then gravity was turned on and then we're like, oh shit, we can't move anymore. These are the same parameters that the earliest life had to deal with.
And Crossland says, "The attraction of gravitation is said to be stronger at the surface of the Earth than at a distance from it. Is it so? If I spring upwards perpendicularly, I cannot with all my might ascend more than 4 feet from the ground."
Oh my god. That's so dumb. The reason... Oh, would you like to explain it, Robert?
So what he was saying is, you don't feel like you're going to go higher because there's less gravity as you go farther from the Earth. But 4 feet relative to 12,000 kilometers, that's minuscule. Of course gravity isn't changed by that much.
You're changing 1 meter out of thousands of kilometers.
Yeah.
The difference between 1,000,001 meters and 1,000,000 meters is essentially zero. Mm-hmm. My god.
But if I jump in a curve with a low trajectory, keeping my highest elevation about 3 feet, I might clear a bound of space above the Earth of about 18 feet.
But you're not going 18 feet high. That's because the x and y acceleration is separate, right? So gravity is not forcing you to slow down going forward. It's only forcing you to slow down going upward. Fuck. Anyways.
So that practically I can overcome the so-called force pull at the distance of 4 feet in the proportion of 18 to 4, being the very reverse of what I ought to be able to do according to the Newtonian hypothesis.
No.
Newton also theorized, and it is now commonly taught, that the Earth's ocean tides are caused by gravitational lunar attraction. If the moon is only 2,160 miles in diameter and the Earth 8,000 miles, however, using their own math and law, it follows that the Earth is 87 times more massive, and therefore the larger body should attract the smaller to it, and not the other way around.
Okay, do you have any comments on that? Because I actually don't know very much about the tides.
So, yes, this is how the tides work, except, like, one thing he's getting wrong here is that actually the tides go every 6 hours. So there's on opposite sides of the poles are, high tides and low tides, respectively. And this is, we used to think it was because of the just reactionary centrifugal force, but it's not. It's due to the magnetic field in the Earth, which is a very interesting, like, assumption that we had to go to. So it still works. It's not this model of just one direction all the time, because then high tide would be 6 hours out of once every day. So
yeah. Huh. Interesting.
But what he's saying here is, like, yes, that is partly how the tides work, and it makes sense, and we experience that. It's not that much.
Yeah, and also something I think is interesting. He mentioned something like, shouldn't the moon be attracted to Earth instead of Earth being attracted to the moon? And it's like they're being attracted to each other, but also if you're looking at the water as an independent system instead of as part of the Earth as a whole, then that's why the water specifically is being attracted more so than like the rest of the Earth.
Right.
Yeah.
If the Earth's greater gravity is what keeps the moon in orbit, it is impossible for the moon's lesser gravity to supersede the Earth's gravity at Earth's sea level, where its gravitational attraction would even further out-trump the moon's. Not to mention the velocity and path of the moon are uniform and should therefore exert a uniform influence on the Earth's tides, when in actuality the Earth's tides vary greatly. Furthermore, if ocean tides are caused by moon's gravitation, how is it that lakes, ponds, and other smaller bodies of standing water remain outside the moon's grasp, while the gigantic oceans are so affected?
Do you have any comments on that?
Well, I mean, I guess they would be a little bit, but it's also like it doesn't do it that much in a lake. I mean, it would be fractions of millimeters at that point. The reason why it's a bit more on in the oceans, because we only have one big ocean, really. I mean, there's a free flow of water, so I mean, it's not even a lot.
Are individual waves caused by like the moon?
Yeah, they're just caused by the tumultuous change in gravity and the heat in the ocean as well.
Yeah, well, because I'm just thinking, like, because if you've been to a large lake, I've never been to like the Great Lakes, but I've been to Lake Eufaula. You can see tiny waves. It's because the body of water is a lot smaller, but they still exist. You're still seeing it on just a much smaller scale.
Mm-hmm.
Thomas Winship says, if the moon lifted up the water, it is evident that near the land the water would be drawn away and low instead of high tide caused. Again, the velocity and path of the moon are uniform, and it follows that if she exerted any influence on the Earth, that influence could only be a uniform influence. But the tides are not uniform. At Port Natal, the rise and fall is about 6 feet, while at Beira, about 600 miles up the coast, the rise and fall is 26 feet. This effectually settles the matter that the moon has no influence on the tides.
Do you actually have you heard of that specific case where like the tidal differences are super big in like a close region?
Well, no, but I think it would have to do something with like water density or whatnot.
And like magnetism and all that? Or
no, not the actual magnet, but like it was a briny creek, so it was a case of a bad statistical like
That
whatever
was
instead of
just like the M, the maths, and the G times M1,
yeah,
M2.
like of course, like trees change as well. Like all those like the amount of water in the lake can happen too. Like if
Okay.
the shape of the lake is weird, that's just how things are.
Mm-hmm.
Tides are caused by the gentle and gradual rise and fall of the earth on the bosom of the mighty deep. In inland lakes, there are no tides, which also proves that the moon cannot attract either the earth or water to cause tides. But the fact that the basin of the lake is on the earth, which rests on the waters of the deep, shows that no tides are possible, as the waters of the lakes together with the earth rise and fall, and thus the tides at the coast are caused, while there are no tides on waters unconnected with the sea. Samuel Rowbotham says, "It is affirmed that the intensity of attraction increases with proximity and vice versa. How then, when the waters are drawn up by the moon from their bed and away from the earth's attraction, which at that greater distance from the center is considerably diminished, while that of the moon is proportionally increased, how is it possible that all the waters acted on should be prevented leaving the earth and flying away to the moon? If the moon has power of attraction sufficient to lift the waters of earth at all, even a single inch from their deepest receptacles, where the earth's attraction is much greater, there is nothing in the theory of attraction of gravitation to prevent her taking to herself all the waters which came within her influence."
It's
But
not changing the density of waters. It's changing how much. It's changing like
where the water is
the
displaced.
nearly the displays perpendicular coming in from like the sides, the
Yeah.
most outer side. It's being like stretched in a way.
Yeah.
So
I hope he knows that like it's not high tide at the same time everywhere in the world.
yeah,
The water when it's low tide in one place, it's high tide in another place because not obviously not that exact same water, but like the amount of water has shifted between them like in an equilibrium. It's not. This guy would benefit greatly from drawing a force diagram, in my opinion.
yeah. But I guess he doesn't know the math for that. So
Let the smaller body once overcome the power of the larger, and the power of the smaller becomes greater than when it first operated, because the matter acted on is nearer to it. Proximity is greater, and therefore power is greater. How then can the waters of the ocean immediately underneath the moon flow towards the shores, and so cause a flood tide? Water flows, it is said, through the law of gravity or attraction of the earth's center. Is it possible then for the moon, having once overcome the power of the earth, to let go her hold upon the waters through the influence of a power which she has conquered, and which therefore is less than her own?
It's
The above and
conquered.
other difficulties which exist in connection with the explanation of the tides afforded by the Newtonian system have led many, including Sir Isaac Newton himself, to admit that such explanation is the least satisfactory portion of the theory of gravitation.
Okay, I absolutely creationists do this all the time as well. They always deflect to like, oh well, Darwin said, well Isaac Newton said. It's like who cares what they said? They lived 400. Well, Darwin lived 150 years ago, but Newton lived in like the 1600s or something. You understand that our understanding of physics has progressed a little bit in the past 400 years. Like it doesn't matter. It's cool that Isaac Newton invented calculus to like do this math. That's cool, but just because he did that doesn't mean that like every single aspect of physics inherently relies on like his original work.
I'm kind of having a hard time following this guy at times because he just kind of like throws like debating-ish words at the topic in hoping
Yeah,
that like he forms a coherent sentence sometimes.
it's very loaded language. And the reason I stopped it there instead of like before was just the fact that like he kept talking about tides and we'd already addressed that. But like I hate the quote mining of like the founder. Like who cares what the founder said? What are scientists now saying?
Thus we have been carried forward by the sheer force of evidence to the conclusion that the tides of the sea do not arise from the attraction of the moon, but simply from the rising and falling of the floating earth in the waters of the great deep. That
What?
calmness which is found to exist at the bottom of the great seas could not possibly be if the waters were alternately raised by the moon and pulled down by the earth.
Okay, isn't there supposedly like isn't Antarctica supposed to be like an ice wall or something? And if so, where is this water coming from? Is it?
I'm not
It
sure.
would still be Earth would more or less be a bowl, right? Even if this were true, unless he thinks that rifts just go into the great deep, and that the Earth is floating on a bunch of water for some reason, even though even by like his own admission, rocks are denser than water. What?
I'm really not sure.
I,
The
I,
oceans aren't that deep either compared to the Earth.
no,
So
we have all the oceans
brings up
mapped
a whole
out.
lot of other problems.
The only places we don't have mapped out would be like
The
Mariana's
deep,
Trench.
yeah, deep
like
seas.
like super deep trenches and like in Indonesia and stuff. But even then, like we would be able to tell if tons and tons of water was just flooding out of there every time it was high tide. You know?
Yeah.
We understand ocean currents and we've like mapped out using radio waves most of the seafloor.
Yeah.
David Wardlaw Scott says, even Sir Isaac Newton himself confessed that the
cares?
explanation of Moon's action on the tides was the least satisfactory part of his theory.
He just
His
repeated
theory
himself.
asserts that larger objects attract the smaller, and the mass of the Moon being reckoned as only 1/8 of that of the Earth, it follows that if, by the presumed force of gravitation, the Earth revolves around the Sun, much more for the same reason should the Moon do so likewise, instead of which that willful orb still continues to go round our world. Tides vary greatly in height, owing chiefly to the different configurations of the adjoining lands. At Chepstow it rises to 60 feet, at Portishead to 50, while at Dublin Bay it is but 12, and at Wexford only 5 feet. That the Earth itself has a slight tremulous motion may be seen in the movement of the spirit level, even when fixed as steadily as possible, and that the sea has a fluctuation may be witnessed by the oscillation of an anchored ship in the calmest day of summer. By what means the tides are so regularly affected is at present only conjectured. Possibly it may be by atmospheric pressure on the waters of the great deep, and perhaps even the Moon itself, as suggested by the late Dr. Robotham, may influence the atmosphere, increasing or diminishing its barometric pressure, and indirectly the rise and fall of Earth in the waters.
What?
I think what he was talking about was like if submarines were to like graze through a globe, they wouldn't be able to like adjust the angle and stay underwater because it would curve out from under them. But like a submarine going in a straight line,
It's still
the
subjected to
parallax
gravity.
the parallax of it going into the air again would be like so minute that as it's going through the sea, the difference in density would keep the buoyancy parallel.
Yeah, I've heard them make that same claim about airplanes.
Airplanes, yeah.
Yeah, but I've never heard them make it about submarines. Okay.
Same reason for airplanes too.
Yeah.
Samuel Robotham says, bearing this fact in mind that there exists a continual pressure of the atmosphere upon the Earth, and associating it with the fact that the Earth is a vast plain stretched out upon the waters, and it will be seen that it must of necessity slightly fluctuate or slowly rise and fall in the water. As by the action of the atmosphere the Earth is slowly depressed, the water moves towards the receding shore and produces the flood tide, and when by the reaction of the resisting ocean medium the Earth gradually ascends and the waters recede, and the ebb tide is produced. This is the general cause of tides. Whatever peculiarities are observed, they may be traced to the reaction of channels, bays, headlands, and other local causes. That the Earth has a vibratory or tremulous motion, such as must necessarily belong to a floating and fluctuating structure, is abundantly proved by the experience of astronomers and surveyors. If a delicate spirit level be firmly placed upon a rock or upon the most solid foundation which it is possible to construct, the very curious phenomenon will be observed of constant change in the position of the air bubble. However carefully the level may be adjusted and the instrument protected from the atmosphere, the bubble will not maintain its position many seconds together. A somewhat similar influence has been noticed in astronomical observatories.
Wait, I was just gonna pause that before he gets to observatories. He keeps saying something about spirit levels. Do you think he's actually talking about like spirits, or is there a term that I just don't know?
I think is he referring to the corkscrew? I kind of thought it was like spirit, like alcohol. Maybe
Okay.
I don't understand it either. I don't know.
I think he also mentioned it with reference to tides, though, and I've
Oh,
never
shit.
seen
I don't know
a lake of Never seen a lake of alcohol enough to like create a tide. But I guess I haven't been to like any frat parties, so yeah, I'll keep playing it, talking about astronomy.
A somewhat
Yeah,
similar
about this.
influence has been noticed in astronomical observatories, where instruments of the best construction and placed in the most approved positions cannot always be relied upon without occasional readjustment. In the past several decades,
What?
NASA has shown video of astronauts
That's so
supposedly
vague. I
in
don't know
low
what he
Earth.
meant.
I have no clue what he was referring to. Okay.
Sometimes astronomical tools aren't
Aren't in the
necessarily
best location.
because of the weather, because of something happening in the sky, because of sometimes it's night, sometimes it's day. I don't know what's that's such a vague statement. I don't know what that means.
Sometimes even the most precisely placed astronomical tools aren't able to see what they want to see because the tide and the moons are caused by differences in barometric pressure and the spirit level.
Congrats, you're not going to see Polaris in Honolulu, really. Like that's a
thing.
Because Polaris is
It's pretty much almost directly north, right?
Yeah,
it almost
so you're not going to see it below the equator. So
yeah. Huh.
I guess in Chile or whatever, yeah, you won't see Polaris.
Yeah.
Earth orbit, experiencing complete weightlessness or zero gravity. How is this weightless effect achieved if gravity doesn't exist?
It's because they're in free fall. That's it. They're falling at the same rate that gravity is pulling them and the plane and all the air around them down. So they're not feeling the rush of air that you would feel if you were skydiving.
They're just feeling no normal force in their pressurized tube.
Yeah. Yeah, it's the same thing in like the ISS and all that. Like there's an apparent weightlessness, but they're still experiencing Earth's gravity because they're in orbit.
The ISS is actually a lot closer to the Earth than a lot of people think it is.
Really? Yeah, I've seen a flat Earth video of flat Earthers observing the ISS go through the sky. Yeah. I forgot what they said their excuse was for it, but I thought it was funny.
There's some island out in like Pacific where the closest humans, if you're on the island, the closest humans during some parts of the day would be the ISS, the astronauts on the ISS. Yeah.
Is it just like an island in the middle of the Atlantic or something?
Yeah, it's like a few thousand kilometers from anything, but the ISS is just...
That's pretty crazy, actually, yeah. I think it must be moving a bit.
Oh, yeah. It's going fast.
As it turns out, for the past several decades, NASA, together with Boeing, have been perfecting so-called zero-G planes and zero-G maneuvers, which are able to produce weightlessness at any altitude. Aboard modified Boeing 727s, specially trained pilots perform aerobatic maneuvers known as parabolas. Planes climb with a pitch angle of 45 degrees using engine thrust and elevator controls. Then, when maximum height is reached, the craft is pointed downward at high speed. The period of weightlessness begins while ascending and lasts all the way up and over the parabola until reaching a downward pitch angle of 30 degrees, at which point the maneuver is repeated. Therefore, all NASA's footage of astronauts aboard space shuttles or the International Space Station can be easily hoaxed and simulated in Earth atmosphere aboard a zero-G plane. In fact, watching footage of zero-G plane flights alongside footage of NASA astronauts supposedly floating around their space shuttles and space stations, no observable difference.
Oh my God, another one. Thank you.
Astronomers claim to have measured all the planets'
titties?
shapes,
come to the Flat Earth Society.
weights, relative.
What is this? Is this? Is he pulling this from like an actual zero-G plane ad or like what?
Why? I mean, if they are, like, bravo on the advertising team. Good for you guys. Sex sells.
Very, very progressive advertising.
They have two great assets that they're trying to advertise here. Really emphasizing their two greatest assets.
I personally prefer to think that he just edited all of it in. This is what Eric Dubay looks up.
Positions and times of revolution, all based on the law of gravitation. And without gravity, their entire cosmology folds under its own weight. Without gravity, people cannot stand upside down on a ball Earth. Without gravity, the Earth and planets cannot be revolving around the sun. Without Newtonian gravitation, Einsteinian relativity, Copernican heliocentricity, and the entire Big Bang Ball Earth mythos cannot exist and falls to pieces.
That's all true. Incredible.
Gravity, both metaphorically and quite literally, just does not hold any water.
What?
Not as a sound theory of cosmology, and not
Wait,
as a
so
law
he doesn't
supposedly
believe in other
responsible for-
planets? Are you reading this? His last point is, oh, why are the wandering stars called planets?
I missed it
Moving.
because I accidentally popped my StreamYard tab into its own window. But what? No, I missed that. I'm pretty sure, like I said, I'm pretty sure flat earthers don't.
No. It's just his last. It's just his last point here.
Yeah, I just went back 5 seconds.
Not as a sound theory of cosmology, and not as a law supposedly responsible.
Like on the board.
Uh-huh.
Yeah, no, I'm pretty sure they don't believe in planets or stars or the moon. Yeah, it's a very interesting mindset.
It's a weird pick and choose system there.
Yeah. Well, I mean, like, I guess everything physical in their reality has to be different. Like, it wouldn't make sense for planets to exist, I guess, unless they're just stationary and just chilling up in the air.
See, one quick thing is, if you ever want to look up in the stars, and wonder if it's a planet or a star, stars twinkle, planets do not, and this is because the light from planets are a lot closer, so your eye can just barely distinguish a little bit of the light coming in, so that's why it doesn't flicker at all. Mm-hmm. So stars twinkle is because they're so far away. The parallax between you and the center of a star and the other edge of a star, it comes in as one beam of light pretty much. So that's
why.
Wait,
so is that the twinkling, is that affected by like gravitational pulls of objects that it's passing at all, or no?
Probably not.
Okay.
That would be, I mean, it would probably be affected by, like, anything in the way, dust, anything like that. So
yeah.
Sometimes the atmosphere,
The atmosphere,
Yeah, that's it.
Responsible for holding in the world's oceans. William Carpenter says, man's experience tells him that he is not constructed like the flies that can live and move upon the ceiling of a room with as much safety as on the floor. And since the modern theory of a planetary Earth necessitates a crowd of theories to keep company with it, and one of them is
that's how science works,
that men are really bound to the Earth by a force which fastens them to it like needles round a spherical lodestone, a theory perfectly outrageous and opposed to all human experience, it follows that unless we can trample upon common sense and ignore the teachings of experience, we have an evident proof that Earth is not a globe.
Okay, why is he so obsessed with the idea that, like, we have to be like flies and stick to the bottom of the Earth? Outside of just the idea that, obviously, gravity is it points towards the center of mass. So even on the bottom, even those Australians are.
It just helps his ego.
Yeah,
that's all he's doing it for.
Flies on the ceiling. Like, the reason they're sticking to the ceiling isn't because of gravity. No one's saying that. It's because, well, I don't know why in flies specifically, but like in my gecko right here, it sticks to the walls because of ionic interactions on its toe pads versus on like the glass or whatever it's crawling on, right? So it actually has like there's a bit of an ionic difference, an induced dipole effect, I think, caused by London dispersion force that gives it an electromagnetic attraction to whatever it's holding on to. And I'm assuming there's something similar to that.
But flies have it because I think they got like
surface area,
microscopic hairs that are.
Oh, and then like the friction force prevents them from falling.
Yeah, they can just they can cling to like any surface because their hairs are small enough to support their weight at like the micrometer range of lengths.
So you're saying it's not gravity?
Yeah. Don't hold me on that.
If we could, after our minds had once been opened to the light of truth, conceive of a globular body on the surface of which human beings could exist, the power, no matter by what name it be called, that would hold them on would then necessarily have to be so constraining and cogent that they could not live, The waters of the oceans would have to be a solid mass, for motion would be impossible. But we not only exist, but live and move, and the water of the oceans skips and dances like a thing of life and beauty. This is a proof that the Earth is not a globe. Gerard Hickson said, "Nearly 100 years ago, Kepler suggested that some kind of unknown force must hold the Earth and the heavenly bodies in their places, and now Sir Isaac Newton, the greatest mathematician of his age, took up the idea and built the law of gravitation. The name is derived from the Latin word gravis, which means heavy, having weight, while the law of gravitation is defined as that mutual action between masses of matter by virtue of which every such mass tends toward every other with a force varying directly as the product of the masses and inversely as the square of their distances apart."
Yep.
Reduced to simplicity, gravitation is said to be that which attracts everything towards every other thing. That does not tell us much, and yet the little it does tell us is not true.
Okay, he just got rid of the equation as like, oh, well, this isn't very specific. It's because he got rid of the specificity in the same sentence.
Yeah.
Yeah.
It's
Okay.
a lot of nonsense.
All right.
For a thoughtful observer knows very well that everything is not attracted towards every other thing. The definition implies that it is a force, but it does not say so, for that phrase mutual action is ambiguous and not at all convincing.
Okay, so gravity is actually a really weak force. Right? You can back me up on this if you want, But like gravity is incredibly weak. And so if you put two pencils next to each other, there is a gravitational attraction, but like the frictional force, just between it and whatever surface it's on, is like way, way stronger. Or, well, I mean, it's not necessarily stronger, it's proportional, but, same sort of concept. The static friction coefficient is way greater than it even needs to be, even if you're on, like, the slickest surface on Earth.
Indeed.
So, gravity is a very weak force, but when you're dealing with giant, giant masses, then it becomes the predominant force that we observe and that affects our universe. God.
I wonder what you would think about how compasses work, because compasses work by like they require so little external force on them to move that the very, very weak magnetic field that we have in Earth's gravity, or an Earth's ball from the rotating convecting heats in our mantle that make up the magnetic field. That's what makes it point north, is it's affected by the magnetic field. Like, how would that work in a flat Earth? I'm not really sure.
It's because Santa Claus has a giant Tesla coil.
So they don't deny the electromagnetic part. They deny some other weird shit. But a lot of like how do they explain aurora borealis? Aurora borealis wouldn't really work if we had a flat Earth. We would see aurora borealis like everywhere at certain times of the day or something like that, depending on like what the angle of the sun was.
Yeah, that's another thing I really don't know how it works, but it's interesting. What was I gonna say? Oh yeah, but all right. So back to my like pencils thing. If you put two pencils really far from any other mass to where the curvature in space-time is like hardly affecting them, then they will eventually move towards each other with some sort of constant acceleration due to that equation. Mm-hmm. It's just, since we're on Earth, that's experienced very, very minimally. Anyways.
Gabrielle Henriette says, "The system of gravitation which makes the sun the moving center of the universe, the awkward principles of which are anything but certain since they apply to invisible circumstances so that they cannot be checked, is here replaced by the old geocentric system, universally accepted until the 17th century, in view, of course, of its undisputable obviousness."
Okay, is that true? I thought geocentrism was like proposed, or heliocentrism was proposed well before the 17th century.
Yeah, it came up before. They knew about.
I know, like Copernicus and Kepler. Was it Kepler and Copernicus?
Yeah.
Yeah, I know that did a lot more like for the math and for the Europeans and stuff. But didn't the Greeks, hadn't they already dabbled in like heliocentrism?
Yeah, it was who was it? Was it Aristotle? No.
I don't know.
It might have been Archimedes again. That proved that proved the Earth was a ball, and to a very high degree of accuracy because he measured the shadow, the length of the shadow at the lighthouse of Alexandria, and then then they measured the one of the tower of something in Egypt, and they compared the shadows and used trigonometry to figure out the difference in the shadow at the same time of day would result in a different angle they made at the sun, hence showing that the Earth is a ball.
It's crazy how they were even able to like synchronize that.
Yeah, and then we couldn't have done it without like a Silk Road, I guess.
Yeah. Well, were they still geocentrists at that point? Just the geo was a ball now instead of a flat plane, or were
they actually knew about it because they studied a lot of the eclipses and whatnot, and it worked out. I mean, they were like, we wouldn't have like annular eclipses if annular is when like the sun can be seen just behind the ellipse, just behind the eclipse. Yeah, and that's because we have elliptical orbits of the around the sun during certain points of the day. Actually, it's another thing to notice is that eclipses can only happen at a certain time of year because the plane at which the moon orbits around the Earth is at a different level of plane than the sun around the Earth around the sun. So those levels of planes, so that the moon can have an eclipse, only happen twice a year.
Is that why like there's different eclipses in different places? Just because like the different planes have to line up.
And that's why you have like blood moons and all the different types of moons during different times of the year, is because it's the cycle of the very, very minute forces going around at certain times in their ellipses around their respective objects.
The more you know.
Yeah.
So going against all logic, the heliocentric model was established. I don't know. I forgot what I was going.
Which the Earth, in a state of immobility and surrounded by the planets visibly moving around it, including the Sun, is at the center of our universe. These two facts, which explain almost everything, are firstly the positive...
Okay, I feel like this meme wasn't created by a flat earther. I feel like it was someone who was making fun of a flat earther.
Yeah, this looks like a shit post.
It really does. Anyways, carry on.
...existence above the Earth of a solid dome constituting the sky, and secondly, the non-material nature of the planets and constellations, which are not physical masses, but merely luminous manifestations without substance. These are the two circumstances...
Wait. Did he just say the sun and the moon?
Luminous manifestation. Stars are luminous manifestations.
I completely missed that.
...of existence. These two facts, which explain almost everything, are firstly the positive existence above the Earth of a solid dome constituting the sky.
How did I miss this the first time? What? Okay. Yeah, there's a dome now.
And secondly, the non-material nature of the planets and constellations, which are not physical masses, but merely luminous manifestations without substance.
Okay, so that's back to what you said earlier. Does he not believe in planets? I guess not.
He doesn't even believe in stars either. He just believes they're
massless illuminations.
What?
How
do you get at that? Like,
really big
what causes
photons.
that? They don't believe. I don't. Occam's razor. Occam's razor. Like, how the hell do you explain that?
God, this is another thing I say to like creationists and stuff. I would love to see the math behind this stuff. Like what okay, so even if you have issues with whatever the currently accepted model is, instead of trying to make up something that doesn't make sense, why don't you think, hey, maybe I don't personally understand this, but someone else does. I would love to see like a flat earther try to design a model that predicts the luminous, massless objects that we call planets and stars.
No, I'm not really sure what they're getting at here. I don't even know how this like.
Oh, sorry. What were you saying?
I don't understand how this would like fit in with religion either.
Yeah, Ian Chen, you missed it. I've talked plenty about the Australians and their world harnesses so far. So, yeah, I hope you're safe right now with your world harness on.
These are the two circumstances which lead today to the fundamental transformation of astronomy. And Professor Bernstein, in his letters to the British Association, writes, "The theory that motions are produced through material attraction is absurd. Attributing such a power to mere matter, which is passive by nature, is a supreme illusion. It is a lovely and easy theory to satisfy any man's mind, but when the practical test comes, it falls all to pieces and becomes one of the most ridiculous theories to common sense and judgment ever conceived."
Huh. So that's the end of the video. We actually went through it a little bit faster than I was expecting, especially with how much I was pausing it and to complain about flat earthers. Oh my god. So has this changed your opinions on gravity and what you're researching? Are you going to be supplanting like the regular math that you've been using for the flat earth math with massless illuminations in the sky?
I probably got to denounce my whole scientific background now.
Dude, you should bring that up in your next like board meeting or whatever. Hey, you're all wrong. Eric Dubay says that gravity isn't real.
What's this guy's credentials, huh?
Pseudoscience? I don't think he has any actual credentials.
Is he like a religious figure or something? What is he?
Yeah.
What does he do?
I mean, most of his arguments aren't specifically religious, as far as I know. He claims to be an author, maybe? I don't know. I really don't know anything about him outside of like Flat Earth YouTube. Yeah, it is interesting. Okay, so apparently a couple of people got pissed off at me. And when I say a couple of people, I mean specifically like John Maddox and who was it? Was it Jungle Jargon or George Bond? One of those two. They were doing a reaction video to a live stream I did on Speed of Sound of Gravity's channel, where I said I was basically defending Christianity. I was saying that, like, you know, just because I would say that we have like enough evidence to say if a God exists, he created the world through naturalism, right? And he used natural processes. And just because something like common descent is, you know, proven, in my opinion, to the same extent as something like gravity is proven, that doesn't falsify a God, right? That just shows, hey, this is how the universe works. And they were like, he thinks gravity and common descent are on the same level. And yeah, I really do. I mean, and you know, the flat earthers, they use the same arguments that creationists use to justify their flat earthness. You know, they use the same holy text and all that as well. And it's like, guys, come on. You know, I don't understand how creationists are going to sit there and criticize flat earthers for doing the same thing that the creationists do. But yeah, and I was going to say, like, my original intent of this channel was to just talk about pseudoscience in general. I wanted to do some anti-vax stuff as well. I still plan on it sometime eventually. It might become a little more prevalent when a coronavirus vaccine comes out. But I remember when I first started my channel, there was all these conspiracy theories about like how coronavirus wasn't real. And it's like, guys, I've taken pictures of viruses before, like with electron microscopes. And so, yeah, flat Earth definitely falls into the category of pseudoscience. What did you think? Have you been very exposed to like flat Earth claims?
I mean, I've watched like documentaries. Sometimes I watch like
what was that?
Funny.
Have you seen that one documentary on Netflix where the flat earthers proved the globe Earth twice?
Yeah, and I love how stylistic that documentary is. They literally, like, the whole point of the documentary is to show that flat earthers are fucking buffoons, but they do it with no narration. They do it with their own, just interviewing the flat earthers about their policies and whatnot, just showing how fucking bogus they are.
That's very true, Ian Chen. Coronavirus is caused by 5G. It's true because he read it on the internet. Abraham Lincoln said that like 3 out of 4 statistics you find on the internet are false or something like that. So,
and he freed the slaves. So,
and he also killed a bunch of vampires.
Yeah.
Yeah.
Good for him.
But what was I gonna say for that? Oh yeah, I don't know. I have a hard time calling. Like I feel like believing stupid things and being dumb are related, but far from the same thing. And like smart people believe dumb shit all the time, right? So yeah. Although I do think people like Eric Dubay is probably a liar and doing it for money, but there's definitely other flat earthers that believe this. So poor guys and girls.
He really does it for money. Wow.
Yeah, well, I mean, he has on his YouTube channel like over 100,000 subs, I think, and he has multiple books.
My God. Okay.
Yeah. I mean, I don't know how many people watch his videos ironically.
Oh. That's sad.
Okay, so his YouTube channel has 72,000. But still, that's quite a few. Yeah. That's pretty much all I wanted to cover. Is there anything else you wanted to talk about physics related?
There was one point I didn't get to mention, I guess. And that's sometimes I hear that like Newtonian, like we argue for Newtonian gravity as some kind of like a ploy that we don't understand like quantum gravity. And that's because at the very smallest scale, when you deal with virtual particles, you deal with weak and strong interactions and whatnot, and you have to deal with all the different parts of the standard model. Newtonian gravity doesn't work there because the other forces are happening at a much different rate, and the actual mass of the particles changed, because what Einstein did and whatnot. So we're having a really hard time sometimes with the whole how quantum gravity works with relativity and whatnot, and that's what like string theory is and whatnot, and how we're trying to weave a unified theory. So string theory is our best bet.
Okay, but what is string theory? I've heard that. I've never fully understood it, but I've heard of it.
Sure. String theory is like a concept who's it was mostly invented by Michio Kaku. He did a lot of the work for string theory, or at least the string theory that we use now, the most common type, because it's been like updated, I guess. Is to solve the relativity and the quantum differences that we're having. He basically had this idea that all mass has these like string-like waves, and it goes through higher dimensions such that the transfer of energy can dissipate in their respective transversal way, like how photons go transversal.
Yeah.
So the consequence of this is that it can explain some of the standard model, but it also relies on relativity working on like multi-dimensionally. So that's why it predicts that there are actually 11 dimensions in total, which is like all the scientific.
Okay, is time a legitimate dimension?
Not in the dimensional analysis sense.
Okay,
that works for the concept of space-time. Yeah.
Oh, okay. Wait, so is time considered one of those 11 dimensions?
I think so. Yeah.
Really? Okay. Yeah, I've always just heard like people saying like the fourth dimension is time, and it's like, okay, that makes sense as far as like in day-to-day life, but I don't really understand how that works with like math. But I'm also not a physicist. Ian Chen says, Lantian et al. 2017, research showed that people who believe in conspiracy theories do so they can feel special and more informed than others. Yeah.
It's true.
That does. I mean, I haven't heard of that study, but that doesn't surprise me at all. Conspiracy theories highlight the Dunning-Kruger effect more than anything else in day-to-day life. The people who are most confident about the flat Earth are obviously the people who are the most wrong about it and probably the least informed about what they're actually talking about. And I see that with creation and stuff as well. Like, I've sort of talked about this. Smokey Saint's debating Erica right now, which I really want to go see that as soon as this ends. But I was watching some of Smokey's debate prep, and it was very clear he didn't understand like how alleles are generated or what even like the basic definition of evolution is. I was in awe of what he also thought that like selective breeding didn't count as evolution for some reason. I don't know. I like I said, I'm very interested to see their discussion because once again, I think the Dunning-Kruger is the only thing that convinced somebody to go up against a PhD candidate in the field that you're talking about without having any knowledge of what you're talking about. Ian Chen says, I thought time was a dimension such as space-time. No? Robert?
Well, yes, that's how it kind of is like modeled in relativity, but it's not exactly in the same way that we have our dimensions, obviously. Like if you ever go into like there's a certain VR simulator that shows how the fourth dimension works and how we actually refer to the fourth dimension. And it shows you that like you can like pick up a cube, but as you like do the slider in the fourth dimension, the cube just disappears and reappears in front of you because it's like our 3D world is moving through a four-dimensional plane that comes out of our dimensional analysis. So it looks like it's disappearing before your eyes, but it's not really disappearing in our space, which is different from how space-time works with relativity. So there is a fourth, like it's not like as if we were to like jump up a dimension dimensionally, we would be in the time dimension. That's not like it doesn't work with like the sci-fi definition of dimension, I guess.
Yeah. I whenever we start talking about like dimensions and stuff, I always think about like what Manny. Do you remember Manny in the common room last year where he was talking about like ants on a piece of paper or something?
I think I do remember what you mean.
Yeah, that's where my mind sort of goes.
Kind of got it right.
Ian, I am honored that you think my stream would be more interesting. Oh, Kasha says that most conspiracy theorists I've heard have severe God complexes, so that makes sense. Yeah, they're more obsessed with being not right necessarily. I mean, they're obsessed with being what they think is right, so that they can scoff at all the people who they think are wrong. Yeah, that's something interesting. Also, we were talking about something quantum earlier. Oh, we were talking about like quantum gravity and how like Einstein overturning Newtonian mechanics is it means that all of physics is falsified, which once again that's another mistake that creationists do all the time. No, physics isn't falsified. But whenever a conspiracy theorist or you see an ad on Facebook that starts mentioning like quantum stuff or like ion anything, just ignore it. Please don't buy any of those negative ion bracelets that you see on Facebook, or like the quantum masks that can suck up the coronavirus from your necklace. Oh my God. Those are scams. My mom would probably buy them if it wasn't for like me and my dad. So whenever she sees something insane like that on Facebook, she's always like, is this real? Like, does this work? No, Mom, it does not work. So Ian Chen says, Kent says, in the end days, there would be scoffers. So now we've identified who they are. Very true. Yeah, like I said, naturalism really is okay, even if you believe that there is something above naturalism, Speed sort of talks about this when he's like, planting a broccoli seed in the ground is evidence for naturalism. Yeah, if that's how you're defining naturalism, I think the disagreement comes because him and Smokey have different definitions of naturalism. But, it's not like God is making sure that the chemical distribution within a broccoli embryo is growing right. It's all within the natural organism. And maybe you think that like God directed evolution, and he has he was really smart, so he like built in this way that everything works automatically, because that's good design in my opinion. But it's also indistinguishable from anything that I would actually consider like natural. But if that's your definition of naturalism, then God works through naturalistic ways, and God worked through evolution, and God works through Einstein physics, like physics as we understand them and all that, right? Just because we don't fully understand something doesn't mean it's dismissed. Okay. Anyways, I've gotten pretty off topic. I think I'm pretty ready to shut down. This was a lot of fun, though.
Yeah, this is good.
Yeah. Is there anything you want to add? Anything you want to shout out?
No. I think Walker put my YouTube, my Twitch. I play games sometimes. So.
You haven't played many games on YouTube since like 2011.
Oh, I've got my old like Minecraft,
your Minecraft videos.
When I was in middle school.
Yeah. That's why whenever you said just shout out my YouTube or something, I looked it up and I was like, yeah, this is what I want to display. Fair enough. Yeah, I don't personally have too many shout outs for myself. If you want to follow me on Twitter, go for it. If you want to follow my or subscribe to my YouTube channel, go for it. If you don't want to do either of those, live your best life. I don't really care.
Indeed.
Oh, like I said, yeah, I'm going over to the Smokey versus Erica debate, so that'll be pretty fun. I would definitely like to see people over there. And then also, I should hopefully have a video coming out within the next. I'll set myself a deadline and say 2 weeks.
Attaboy.
So hopefully I get that done. Yeah.
All right.
It's been great.
Sounds good. Yes, I had fun. Thank you for inviting me, Walker.
Oh yeah, of course, my dude. All right. See everybody later.
Take care, guys. Bye.